right join here, right outer join. Full outer join is both of them. You just union them. You see this one and you add this one, but you should keep the order. So remember that join you join normally as we did here for equality, A equal D or E equal C. And then finally you should take the one in the left join, the one that doesn't participate in the join, which is 34. And in right join, you take from this one that doesn't participate in the join, which is 340. Full outer, you combine them. Union. What's the division? The division is so easy. First thing to talk about division of R divides S, or S divides R, or is a divisor, it means that S should be subset of R, is a part. So if R has A1, A2, AP, AP plus 1 to AN, S can be A1, A2, AP. So as you see, it's a subset, it's a part. To do division, S should be a part subschema of R. The schema of T result is the subschema of R, which groups together all the columns of R. Look, T is the subschema of R, which groups together all the columns of R which do not belong to the schema of S. Attention. It groups together all the columns of R which do not belong to the schema of S. So it's TAP plus 1 to N here, because this one is the same, so we don't take, we talk the rest. For a tuple T will appear in T, result of division means that the values of T must appear in R in combination. Look, the values of T, which is the in T, must appear in R in combination with each tuple of S. We will explain an example. This is an example. As you see here, this is R, SID, SName, CID, CName. Numbers, varchar, numbers, varchar. And as you see here, CName, S is CID and CName. And as you see, CID, CName, so S is a sub part from R, right? So here I note something important. So R divide S returns the tuples in R, returns tuple in R that are related to all tuples in S. For example, one row should be related to this one and this one and this one. If this is true, we will add it here. If a row here relates to 1, 2, but not to 3, we don't add it. It should to all tuples in S. It should relate to all tuples in S. So find the students who took all courses listed in S. Find the students who took all courses in S. So it means that they are related to all lines. So students who are associated with all courses in S. So let's do it. We take the first one and we check 1 JAD 10 Java. Look to the part 10 Java. Is JAD took 10 Java, right? So 10 Java here relates because Jad took 10 Java as here. So this is okay for the first row. We should check now if Jad took 20 C++. Is Jad took 20 C++? Jad took 20 C++. So this is also true because this relates to Jad. Let's check for one Jad. One Jad, is one Jad took 30 PHP? Yes, it took. So Jad took all rows as here related to all tuples in S, as you see. 10 Java for Jad, 20 C++ for Jad, 30 PHP for Jad. So you add one Jad. You add one Jad, but you don't add this information in the division. If you divide this by this, as you cancel this for Jad with this. So the remaining one is one Jad. Let's go to Sami. To Sami. Sami relates to 10 Java. This is okay. Sami here relates to 20 C++. 20 C++ is okay. But there is no Sami relate to 30 PHP. So we don't take. Why? Because the condition to all tuples in S is not satisfied. So we don't take Sami. Let's go to Fadi. Fadi 20 C++, 20 C++ is okay. And no more Fadi. So Fadi satisfied only one tuple, not all of them, so we don't add. So the one is for only one Jad or Jad. You should find the tuple here that relates to all. Relates, it means that they should take this course. As here. Jad took 10 Java, 10 Java, took 20 C++, 20 C++, 30 PHP, 30 PHP. So now operation is called the complete set and expression R intersection S. R intersection S is equal to R minus S or S minus S minus R. R joined to S using condition is equal to selection. This is very important here. So the join R join S based on condition is equal to selection using this condition on R cross S. As we said before, the join is first you do cross product, then you use selection using this join condition. So we are done. The slides has been finished or over. So we should solve the exercises, okay? Now we should solve the exercise. IUL database fundamentals. Where should be the solution? Solution of series 2 here. Here we should understand today. This exercise. Okay. So imagine that we have this relation. Student R, relation R. Student E1, 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 E2, 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 E3. Okay. and course M1, M2, M3, M1, M2, M3, M2. Okay, T1, T2, T3, grades 15s and 14s. Imagine that we want to create a projection on course here on this relation R. What would be the result? Remember, projection, you should remove duplicates in the result. So we will have a new relation with only one column, which is course. So imagine here, take this one, course, okay, and you should remove all the duplicates. So M1, M2, M3, they are not duplicated yet. M1 is duplicated, we don't take it. M2 duplicated, we don't take it. M3 duplicated, we don't take it. M2 duplicated, we don't take it. So the result is M1, M2, and 3. You see? We don't take the, because M1, M1 two times, M2, M2, M2 three times, M3, M3 two times. So we only take one version or one copy of each one and write it in the relation. So the projection reduce the number of the cardinality because of the elimination, or because we delete the duplicates. Okay. Second example, project teacher course. Now will project teacher and course, or course teacher. So teacher course, the new table will only have teacher course as a relation scheme here. What should be the projection here? Projection teacher course. Remember, if we want to do here projection and to eliminate the duplicates, we it should be repeated teacher course together, not teacher and not only alone course. As an example, M1, T1, M1, T1, M2 is not yet duplicated. T2, M3 is not duplicated. T2, M1 is not duplicated. There is no TM1. T2, M2, T2, M2 is not yet duplicated. T2, M3 is duplicated here and here. So we take it one time. T3, M2, it's not duplicated. You see, we take them both and check if they both together are repeated, as this and this one, and we can this one. So 1, 2, 1, 2, 3, 4, 5, 6, 7, and this is 7. So because we eliminated 1, the result should be 6 instead of 7, and we will not have duplicates. Let's check. Teacher course T1 M1, T1 M2, T2 M3, T2 M1, T2 M2, T3 M2. There is no duplicates. 1, 2, 3, 4, 5, 6. 6 here, number of 6 because we eliminated 1. Here 7. 1, 2, 3, 4, 5, 6, 7. Okay?